Let's explore the fascinating concept of square roots and understand how they work. A square root asks, what number times itself equals this value? For example, the square root of 4 is 2, because 2 times 2 equals 4. Let's start by understanding what a square root really means. A square root is the inverse operation of squaring. If squaring means multiplying a number by itself, then square root means finding what number was multiplied. Mathematically, if x squared equals a, then the square root of a equals x. Here's how it works. 3 squared gives us 9, and taking the square root of 9 brings us back to 3. They're inverse operations. The square root has its own special mathematical symbol. This is the radical symbol, used to indicate square root. The number goes under the horizontal bar. For example, the square root of 16 equals 4, because 4 times 4 equals 16. Visualizing this, a 4 by 4 grid contains 16 squares. The square root of 16 tells us the side length is 4. Some numbers have whole number square roots, called perfect squares. Perfect squares are special numbers whose square roots are whole numbers, like 1, 4, 9, 16, and so on. Here are the first 4 perfect squares, 1, 4, 9, and 16, with their corresponding square roots of 1, 2, 3, and 4. The pattern continues. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Most numbers are not perfect squares and have decimal square roots. Numbers like 2, 3, 5, 6, 7, and 8 are not perfect squares. Their square roots are irrational decimal numbers. For example, the square root of 2 is approximately 1.414. This decimal never ends and never repeats. Here we see the difference. The square root of 4 is exactly 2. The square root of 5 is approximately 2.236, and the square root of 9 is exactly 3. Square roots follow important mathematical rules. The square root of a product equals the product of the square roots. The square root of a times b equals the square root of a times the square root of b. For example, the square root of 36 can be broken down as the square root of 4 times 9, which equals 2 times 3, giving us 6. Similarly, the square root of a fraction equals the square root of the numerator divided by the square root of the denominator. For instance, the square root of 16 over 4 equals 4 over 2, which simplifies to 2. Square roots appear in many practical situations. In geometry, if we know a square has an area of 25 square units, we use the square root to find that each side is 5 units long. Square roots are used everywhere, calculating distances using the Pythagorean theorem, finding areas, in physics formulas, and throughout engineering. Let's review the key concepts about square roots. The square root asks a fundamental question: what number, when multiplied by itself, gives us this value? Perfect squares are special because their square roots are whole numbers, making calculations easier. We can simplify complex square roots using the multiplication and division properties. Square roots are essential in mathematics and appear constantly in real-world applications, from construction to physics.